everyone, welcome to day 26 of the 30-day coding challenge from CS and Math. Yesterday we looked into statistics of home run hitters. I was planning on doing standard deviation and median. Within that conversation just got a little bit long, but we did get an algorithm for averaging that was pretty solid. So let's just finish that off today, and we're going to get in there standard deviation, median, and if there's time I'll talk about matplotlib. So jump into Trinket, and let's just do a quick review of what we did yesterday. So sometimes a nice thing to do if you think kids are struggling at all, is just to throw in an extremely easy number set, one that you can, let me full screen this just to get it clean. So if you're like, oh, well, I'm not sure if they're understanding, just create a fake data set, one that's easy, and see if you can get it to work. So again, our approach was to total up the entire list. So we'll initiate a variable at total, and we wanted to be like, okay, let's take 1, add 2 to it, add 3 to it, add 4 to it, and just get a sum total. And remember, the way we did that was we did a loop. We said for I in range. In this case, there are 1, 2, 3, 4, 5, 6, 7 numbers. So for item in range 7, what we're going to do is we're going to take this first index or grab this first value 1. And so to do that, we'd say take the total, previous total, which was 0, and reset it, reassign it to the total plus numbers is the name of that list, but retrieve at a certain spot. For instance, if I said, if I put a 0 in here, right? Actually, let me just go below and I'll just say print, I'll just print that, right? Just to make sure we got it down. So if I run this now, see how it retrieves the 1? It retrieves that this is the 0 term, first term, second term, third term, and so on. Okay, so as we do this, though, we want this number to bump up, not to stay constant at the 0 term. We'll go to the first term, second term, and change. And yesterday we said that that value is equal to the value that we've assigned in this loop. So that's confusing. You can go back and watch yesterday's video, but that's what we did. So we reassign that total to this running total, and then at the end we just printed total to make sure it was working. Or we could put it in the loop like that. So notice that it's got 1 plus 2 is 3, 6, 10. You can see that the running total is kind of running up until it hits the end. But we don't need to print all those, right? So we took it out of the loop and we ran it and just got the total. So that was the total, and then we said, well, we really are trying to do an averaging function, so let's set the average equal to that total. And really we said the best way, instead of just using a constant number like 7, because if you add a number to this list, then you're going to constantly have to go back and change this code. So the better way to do that is to do the length of numbers. And remember, length of numbers, if I stole this now, if I print this, oops, if I print this, is 7, so it's printing just the length right now. So we're taking the total of 28 dividing by the length of 7, and then obviously we can change this print statement to the average. So the average is 4, which makes sense because the outer, or the smaller and the larger, the lower bound and the upper bound average out to 8 as you go up, right? 1 plus 7 is 8, 2 plus 6 is 8. And for that reason, it makes it very easy to see why this would average out to be 4. So this would be a good one to do with kids if you think they're struggling with it, to kind of hammer out that algorithm. Now the standard deviation approach is going to be very similar, so let's do that first, and then we'll end with the median. Now I'm going to pull the code back up from yesterday. If you didn't do yesterday, you could obviously pause and type this code in if you wanted to take the time. So this is basically the code from yesterday. The lists are fairly long, which is why, like I said, if you wanted to go and type these in, you could. but we'll be doing standard deviation and median with these data sets of famous Yankee home run hitters. So go ahead and pause if you want to get that down. Okay, now to clean it up, remember this function was actually meant to just average. We just left it off, doing these different things. So let's get the total and everything out of there, and just at the end have it print the average. So now if I run this, Babe Ruth's average was this, and on down the line, Lou Gehrig. So we can tell Babe Ruth's average measure of center was certainly higher than the other three, which were pretty consistent around 29. That's really interesting to think about and know. So on average, you'd expect Babe Ruth to be hitting a few more home runs per year than the other three. And he's, played a lot of years. Now, we also want to have some evidence of consistency. So these are measures of spread. Are they bouncing all around? And do we have a statistic that can show that? So let's just, for sake of ease, let's just focus for right now. I'm going to just turn this code off. Remember I showed you yesterday how to turn that off? We could do this. 3 quotes around those 3 players and just leave them out for now. So go ahead and get that set up, and we are going to dig into standard deviation. Okay, so I've kind of went in here, and we want to use the average outside of this function that we created, and it turns out that we assigned AVG average. We defined that variable inside of that function. So I added in this line of code that says global average, so we can retrieve it out here. So go ahead and add that into your definition. And then, so if I run this now, it won't actually print the average. It wouldn't print anything. I had run the deviation over there. So what we want to do is for Babe Ruth, let's say we want to access this first year of 0. The deviation means, let's call it DEV for deviation. We want to access Babe Ruth's first year, which is defined as the 0 place, right? And subtract the average from it. So how far did this year deviate from the average? And if we run that, I guess we got to print that, right? So we got to print deviation. If I print this, notice how it says, oh yeah, you're 32.45, which was the average, below the average. So that is how far I deviated that first year. So let's go to one where the deviation would have been positive. So 0, 1, 2, 3, 4, 5, 6, 4, 5, 6. So the 6th year would be 54. So if I change this to 6, that was the first year that it produced a positive, like he was above average that year. And then he had a series of years where he was above average, right? And the average was drawn down or pulled down by some of these potential outliers. We could discuss that maybe too at some point. Do you throw those out or do you keep that in? So this would print each individual deviation. Now, if you look up standard deviation formula, which I've pulled up here, if you look at the formula, you want to take the actual data point. Xi means each value from the population. We do have the full population of data here, minus mu, which is typically in statistics assigned to the average of the mean. So we're going to take every data value, subtract the mean, which we did 2 examples of. We're then going to square that. We're going to summate those or total them all up, divide by the population size, and then square root. So we have a couple of orders of operation. Let's try to put those in. So as before, when we did a summation, I put in this line of code for item in range, the full length of the data set. We're going to put this deviation piece, tab that in. We're going to delete this print statement for now. But we're going to get this running. And what we want to do is not just the 6th year, but we want to, as we loop through this, we want to keep bumping up through the first or the 0 term or the first year, 2nd year, 3rd year, and keep rolling through them like we did for the average. So this will get all the deviations that way. So you can get that set up, and then remember we have to square that and summate. Okay, so now we have in here, this was the deviation. We're going to, it doesn't really matter what you call this, it's just kind of a placeholder, but we're going to square that deviation. So remember, whatever that deviation was, we want to square it in the formula. So this is the deviation squared. And then we want to keep a rolling total like we did for the average as well. So now you're going to do, I just did sum instead of total. Sum equals sum plus this new squared value. I suppose we should declare this sum originally to be 0 to reset it at the beginning so that it does that, and then this should keep a running sum for the full length, and then at the end, just to make sure, we could print the sum. So let's run that, and notice how it prints the sum here at the end of the deviations. So see if we can't get that rolling. Okay, then to finish off, we're really trying to print the standard deviation. So what we're going to do for, a lot of times they'll call it stdev. Different functions are called stdev, so I'll just call it that, standard deviation. Or what we want to do is take the square root, so I type in sqrt, but remember it's not going to like that. It's because in previous videos we talked about that for square rooting you need to import the math, import the math module. So let's do the import math, and then we can do math dot square root, and we're going to take the square root of, in the formula you take the square root of this summation, which we called sum, divided by the length. So I would say sum divided by the length of, in this case, babe. And then instead of printing the sum, we print stdev. So if we run this standard deviation is what prints out here. Now we want to get our kids to be big on verification, right? So the first thing I did right away was I just Google search standard deviation calculator. They could use TI or whatever if they're comfortable with that. But they definitely want to verify. So I took Babe Ruth's numbers, I copied them, and I'm going to paste them in here. Now we have his full population of home runs. It's not a sample, which changes the formula so that if it's a sample, we want to include more of an error range, so you divide by n-1, but we do have the full population, so I'm going to calculate, and it looks like we are calculating here correctly. So it gives the different things, gives the variance and some other statistics, but this is good confirmation that what we printed out here was accurate. So with a little more time, I could go through more thoroughly how to make this into a function that takes in different parameters, but I think this is good. What we really want kids to do is to think through how this standard deviation process works and then come up with that for each player. So you could easily change this from Babe Ruth to Lou Gehrig in 2 spots, 3 spots I guess would be. But I'm not going to take the time here. What I am going to do is go back to that original really easy data set and just show you, pop up the code for median and end for today. Okay, so you can get rid of the 6 and the 7, just 1, 2, 3, 4, 5, and I'm just wanting to print that, show that we can print this, and we can assign the length, we can assign that a variable, let's say like n, and then there's a sort command like this. So now if I run this code, it will still print this way. So I want to change the print statement. Instead of here, I want to print num here. So notice if I print the list after the sort after I call this sort command, then it sorts it out from least to greatest. Now, a lot of times if you're going to hand type this, it does it manually, but if you're going to import stuff from a spreadsheet, then you'll want to have this access. Okay, so what we've added in here now is some divisibility. So if n, which is important, why do we assign this length to a variable? Because we want to use it a lot now to determine the spot in the sequence. So if the list length is divisible by 2, this is called a modulo. So if it's divisible by 2, meaning the remainder is equal to 0, which this one's not because it's 5. If this is true, run this, else run this. So in this case, we're running this second one. Now notice this is retrieving, this is indexing because of the brackets. You're indexing, again, a variable term from there. So you take that list length, n, divided by 2. Well, 5 divided by 2 is 2.5. So where do you go with that? Well, if you do 2 divisions, it's called a floor division. So I searched that to help you out. So floor division, I could try this. Rounds the result down to the nearest whole number, if you were wondering. So, for example, this would round down to 2, which is what we want because remember Python starts at a 0 term. This would be a first term, this would be a second term. So if it's an odd number, meaning I hit this else because I didn't meet this condition, then it goes to the floor of 2.5, which is going to be the second term, 0, 1, 2, and then print the median is 3. So notice that works. If I change this data set by, let's say, putting a 6 in there and run it again, notice how it says the median is 3.5. Well, now it did meet this condition because the length was divisible by 2. There were 6 things in there. And it said set median 1 equal to that floor that we just did before, but also the floor minus 1, and find the average of those two, which is what it did here. So very nice algorithm. I actually didn't come up with this algorithm. We've used a similar one before. I stole this. This is very important to kind of mention. You can learn from other people. So I got this from Geeks for Geeks. I used their approach. They had a mean approach. They had a median approach, and they also have a mode approach. So what I searched to get that was median code in Python, and you could do the same thing and even learn about mode. So we're way over time from our usual video length. Hopefully, if you've stuck around this whole time, you found it helpful. Hit that like, hit that subscribe, and we'll catch you next time for day 27.